scalar triple product. We're simply going to see how to find the scalar triple product. Suppose you have three vectors. I'm going to go for the simplest case. Yes, we know what the vector that is perpendicular to both of them is, do we? Yes, right this way. And we know when we find the cross product of A and B, we end up getting a vector C, but its magnitude would simply be equal to
0. Oh, in a crossword.
You know, in terms of practice, what is the meaning of the length of that cross product of A and B?
It's just the product of the lengths of vector A and B. The product of the magnitude.
Product of the magnitudes, okay, geometrically speaking. Do we have to play the word game? Four-letter word, starts with the letter A, ends with the letter A.
Area.
Area. Yes, from last time. I'm simply going to add another dimension to area. What will I get? Volume. Let's say that is the height, C. Good? Yes, good, maybe.
You drew that really well.
Yeah, I was gonna say that. I was like, wow, that was good.
Okay, thanks. That's right. Simple cube, correct? Going back to last time. Simple rectangle, stretch it. What do you get? Parallelogram. Yes. Simple cube, stretch it. What do you get? I messed up earlier today. I wrote the wrong thing. Parallelepiped. So the volume of this cube is simply A. Correct? Now, how do we get A? Well, if you did C vector dot A vector cross B vector, the vector triple product. But if I put magnitude, I get scalar triple product, yes? So if I simply took the dot product between this and, you know, those two, in this case, I'm simply multiplying length times width times height, volume of the cube in this picture. So here, simply volume of the cube, picture to the left, my left. Good. If I made this C vector slightly over to the axis, this is going to move, agree? That is going to move. That is going to move. They're all going to move, but will the volume change? No, just like last time. We had a rectangle, stretched it, the area still is the same. Same. If you tilt it at an angle, you will end up getting the volume of the parallelepiped. So in general, C vector is at an angle theta not equal to pi over 2 from z-axis, then the scalar triple product, because the result is a scalar, simply the volume of the parallelepiped formed by A vector, B vector, and C vector.